One way to charge an object is through friction and contact. So we can see in this top image here, this guy has balloons being rubbed on his head, and so the balloons are both stealing electrons from his hair. Now this makes both of these balloons negatively charged, and since opposites attract and the same will repel, that makes these two balloons repel each other. And when he stands next to the balloon, the negatively charged balloon and his positively charged hair will be attracted to each other. Another way to charge an object is through induction. You can see this on the bottom image here, where there are these two spheres and a negative charge is brought next to, not even touching, just next to sphere A over here. And since opposites are going to attract, that pulls all the positive protons towards this negative charge, and the negative electrons are going to scatter away far into this sphere B over here. And as you're pulling it away, it's these two spheres. A is going to be left positively charged and B is going to be negatively charged. So for your new unit on electricity, you're definitely going to need to know Coulomb's law. So this is what you should have on your formula cheat sheet. And to understand it, know it's pretty similar to your gravity equation, because electricity is in a way like gravity. So if you have a gravitational attraction between two objects and you're measuring the distance between them and the force of that attraction, it's pretty similar. Except now you're just measuring the electrical attraction or repulsion between two objects. So in your study guide, they give a very fancy sounding statement about Coulomb's law, which says, Coulomb's law states that charged particles or objects that are small compared with the distance between them, the force between the charges varies directly as the product of charges and inversely as the square of the distance between them. That's a pretty big mouthful. So if you can understand that, great. You're awesome. But for those of you who are a little bit unsure, just to give a quick explanation in a bit simpler terms, it's talking about the force, electric force between two particles or objects is going to increase with smaller distance. So these two charges are going to be a lot more attracted to each other than these two down here because they are further apart. However, if the magnitude of the force is a lot stronger, say with these it's just a little bit, with these the magnitudes of the forces a lot stronger, then they might actually be more attracted to each other than these two up here. If you're still confused about Coulomb's law, there's a great video I found for explaining it that is in the playlist down below. It's called Coulomb's Law with Examples by Up and Atom. And Atom spelled like the particle, not the name. It's a great video, gives great examples in English, and very helpful. Also be aware that two positive charges are going to repel each other, as well as two negative. So if they're the same, they're going to repel, and opposites are going to attract. Circuits have a lot of different parts to them, and I've drawn out here the symbols that we use when doing certain circuit diagrams. So we have a battery, which is going to give the charge and start the electrons flowing through the circuit. The wire, which is going to act as your conductor. Resistor, you need some form of resistance in your circuit, otherwise in your equation you're going to have resistance as 0 in the denominator. That does not work mathematically and physically. You could start a fire and we don't want that. You have a capacitor, a diode, a bulb, and a switch, both in open and closed position. Now over here on the right, we have what is called a series circuit. So the battery here is going to add the charge, and say it's going in this direction. It's going to go light up this lamp and come around, but the switch is in the closed or open position, so the electrons cannot flow and complete the circuit. Now if you close the switch, then you would have a complete circuit, and the electrons would be able to come back into this end of the battery and continue lighting up the lamp. If this switch is open, you're not going to be able to light up this lamp just because you need a complete circuit. So that is a series circuit. A parallel circuit over here is identified by the ability for the electrons to take different paths. So if the electrons wanted to go down here and write it to this bulb to light it up, they could come right back around here and complete that circuit. Or they can continue going further and light up this bulb and come all the way back around. So there's several different paths that the electrons can take. And if this bottom circuit were somehow broken or a switch was put in right here, you could continue lighting up this light bulb right here, but this one would not get any power. Whereas in a series circuit, if you added another lamp right here or anywhere on the circuit, if one part of the circuit is broken, neither of the lamps would turn on. So that is going to be all the parts of a circuit.